Okay, so here's our last three examples here. First of all, I think I called, ooh, nice voice crack, Molly. I think I called this omega last time. It's definitely not, it's theta. Um, Greek alphabet. Been a while since I've had to use theta, so I apologize. That's what you're going to see in these situations. They like to use that in your trig function. Um, so these are the situations where we need to find the third side before we go ahead and answer our questions. And why is that? Well, when we're finding cosine of theta here, so katoa, ka is CAH, cosine is adjacent over hypotenuse, right? Well, our hypotenuse is unknown right now, okay? Now, when we go ahead and find that, what they want, give an exact value, not a decimal approximation, here's why that is. When we're trying to find the hypotenuse, again, we're looking at our a squared plus b squared equals c squared. We're looking for that hypotenuse, which is that missing c value. Doesn't matter which leg you call a and b because they're both being squared and added up. So you've got 8 squared plus 15 squared is equal to c squared, which is going to be 64 plus 225. Oh, it's not. Yeah, 225 is 15 squared is equal to c squared. And then those two added up are going to be 289 equal to c squared. Now, when we go ahead and take the square root of that, in this instance, you're going to end up with a nice whole number for your c. That is not always going to be the case, which we're going to see in the last example. So the square root of that is going to be 17. So that's your hypotenuse. You get a nice whole number. So when they want you to find that cosine, they don't want you to simplify or divide that number out. Leave it as a fraction. That's all they want. Okay? So your cosine of adjacent over hypotenuse, well, we're talking about this angle theta. Adjacent in terms of that angle is going to be this side 8. And hypotenuse, regardless of the angle, is that longest side, which is 17. And that's your answer. You're just leaving it there. Okay? Cosine of theta in relation to the angle labeled as such is going to be that adjacent side of 8 over the hypotenuse of 17, and you're done there. Okay? Now, taking the actual decimal measures of these angles on a calculator, there's a few different ways, obviously, that some of us use a calculator. Some of us use our smartphones. Some of us have a calculator. And some of us may end up Googling that or using a Google calculator. Some of us may end up using that Alex calculator. There's a number of ways to do that. Now, on most calculators, which Google calculator, the Alex calculator, and probably most of you with any graphing calculators, what you're going to end up doing, they have buttons for these functions. So you would end up typing in cosine, and then they'll give you parentheses. You're going to type in 21, and then you have to make sure you close the other parentheses. Not all calculators actually close that for you, so you're going to hit the other parenthesis button. And you're going to end up with a big long decimal, 0.93358, and on and on and on. Okay, they want us to the nearest hundredth, which is that second value. Okay, the 3 does not round the first 3 up. You're done at 0.93. That's rounded to the nearest hundredth. Okay, sine of 50. Now, if you're on a smartphone, well, if you're on an iPhone anyway, I'm assuming most smartphones operate the same way. You have to type this in a little differently. What they want you to do on the iPhone is you're going to type in that degree measure first, 50, and then you're going to hit the sine button, and it will take sine of 50. Okay? And that's going to end up giving you 0.76604, blah, blah, blah. Again, nearest hundredth is going to end up that 6 rounding the first 6 up is 0.77, and that's going to be your rounded sine of 50 degrees. And then tangent of 75, again, calculator, you'll hit tangent and then use the parentheses with 75. Smartphone, you're going to type in 75 and then hit the tangent of button. And for that measure, you will end up with 3.73205, blah, 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 rounding to the nearest hundredth will end you right there. Okay? So typing those into your calculator, you get those exact values, or rounded values in this case. Just make sure you are typing in correctly for the type of calculator you're working on. And then last, we are finding multiple different measures, functions, I should say, cosine, secant, and cotangent. Again, you have all those written down further up on these notes. You have them on that sheet of notes that you either have as a paper copy or attached to the checklist. And it's another scenario where we have to make sure we are finding the missing side. Now, this is where we're going to end up using exact values. It's not going to be a nice whole number there. And we're going to leave it as that square root. So your missing side is a leg. We can call it A or B. It does not matter. So one of your legs squared plus 3 squared for the other leg is going to be equal to that hypotenuse squared, 4 squared. A squared plus 9 is equal to 16. I subtract 9 from both sides, and I'm left with A squared equals A squared equals 7. I kind of jumped ahead of myself there. So when you take the square root of both sides to cancel out that squaring, 7 is not a perfect square. That's going to give you a long, ugly decimal. This is where they want exact answers. We're not going to round to that. We're going to leave A as equal to root 7. Okay? So your missing side in this case is going to be left as that exact value root 7. Okay? So now when we go ahead and find these 3 different trig functions of our triangle, okay, in terms of that angle theta, the hypotenuse is always the hypotenuse. The adjacent is that side next to it coming off the other side of the angle. And that opposite is going to be the 3, straight across from that angle. Okay? And then you're just making sure that you're looking at the right function and how it's evaluated. Okay? For cosine of theta, we're talking about adjacent over hypotenuse, which is going to be root 7 over 4 in this case. In Alex, I would click the fraction button first, because if you do square root of 7 and then hit the fraction button, they are going to include the 4 under the square root. You would have something like that. That's not our answer. It's a root 7 on top and a 4 by itself on the bottom. So click the fraction button first, so you have the root just on top. So that's your cosine. Secant of theta. Okay, secant, if you look on our cheat sheet or that page further up in the notes, secant is that inverse of cosine. It's the opposite of cosine. So you're going to end up with hypotenuse over adjacent, which is just the cosine flip. So that's going to be 4 over root 7. And then finally, scroll down just a little bit here. We're looking for cotangent of theta, which is going to be that adjacent over the opposite. And that's going to end up being adjacent of root 7 over the opposite side of 3. Okay, so today is just really getting you familiar with these trig functions, making sure that we're picking the right sides. You need to use a little bit of that memory with the Pythagorean theorem to make sure we're finding all sides when that is necessary. And just make sure that you are using your notes as we're getting used to these trig functions and making sure we're picking the right sides for each function. And that's all we've got today. And let's get to work on the homework and be efficient today.